Right now, the smartest companies on Earth are betting hundreds of billions of dollars on a machine that has to be colder than outer space just to switch on. Google, IBM, Nvidia, all chasing the same dream, and I'm one independent engineer with a laptop in Saltillo, Mexico, about to tell you they might be missing another road. Not a magic road, not a this kills quantum road, a cheaper one that we could build with the hardware we already have. And I'm going to do something almost nobody on this platform does. Before this video ends, I'll tell you the exact part of my idea that's brilliant, and the exact part I had to throw in the trash. Stay with me, because that second part is where it gets real. For 20 years, quantum computing has promised us the future. 20 years. And it's genuinely incredible science. I'm not here to mock it. But let's be honest about the price of admission. Each machine costs millions of dollars. It only works at minus 270 degrees Celsius, colder than deep space, almost absolute zero. It needs its own cryogenic chamber, its own army of physicists, its own building. So a question started keeping me up at night. What if the entire industry is so hypnotized by quantum that nobody's asking the simpler question? What if the bottleneck isn't raw power, but density? How much meaning we can squeeze from the bits we already have? Let me ground this. Everything you're using right now, your phone, your laptop, the server streaming this video, runs on bits, zeros and ones, one at a time. That system has carried humanity for 70 years, but it's hitting a wall. Chips can't keep shrinking forever. Physics pushes back. The industry's answer is, go quantum. My question was the opposite. What if we go deeper into the bits instead of running away from them? So here's the idea I called multibinary computing. Instead of reading bits one at a time, we group them into blocks. We raise those blocks to powers. And we combine them using something beautifully old, Pascal's triangle. The same one you maybe doodled in school, now doing serious work. It sounds insane, I know, but the mathematics holds. The engine underneath is a concept called finite rings, and don't let the name scare you. Here's all it means. Each block of bits becomes a number. We raise that number to a power, and a Pascalian matrix fuses all those results into one richer structure. Same input, the same zeros and ones you started with, but the amount of meaning packed inside changes completely. Let me make it physical. Picture a box with 100 pieces, all the same color. That's classic binary. Now picture the same box, the same 100 pieces, but each one can be many colors at once in combination. Suddenly, the number of distinct things that box can represent doesn't just grow, it explodes. And the kicker, no cryogenics, no minus 270 degrees, no $1 million machine in a sealed room, just smarter math on hardware we can actually afford. Now, I made you a promise, the part I had to throw in the trash. Here it is, straight. My original dream was bigger. I believed this could replace quantum computers outright. Do everything quantum does, cheaper. And I had to ground that, hard. Because when I pushed the physics to the limit, that version wasn't viable. Not the way I first imagined it. Saying that out loud cost me. It bruised the ego. It would have been easier to keep selling the fantasy and let you believe it. But that's not who I am. And it's not what this channel is. Truth first. Always. Because an idea that survives honesty is worth 100 ideas built on hype. So, what survived? The part that genuinely excites me, and nobody saw it coming. What if all this multi-binary math didn't try to replace your computer, but lived on its own dedicated chip, a card you plug in, exactly like an NVIDIA GPU? I call it the Multibinary Coprocessor Module, the CMM. Picture a small independent motherboard, its own CPU, its own GPU, its own RAM, even its own fan. Because it runs hot, it processes differently, so it needs its own cooling. And here's what makes this credible instead of crazy. Architecturally, this is the exact same path the giants already walk. NVIDIA's Grace Hopper, the OAM modules from the Open Compute project. Dedicated accelerator cards are the future. I'm just proposing a different brain inside one. And this isn't a daydream in a notebook. It's registered intellectual property, with Endaughter, with Safe Creative. And there's a patent application currently pending before IMPI here in Mexico. In process, not granted. And I'll always tell you exactly where it stands. Why should you care? Because if a direction like this matures, the implications are huge. AI is starving for compute, and the energy bill is becoming a planetary problem. Data centers are drinking electricity like never before. A path that packs more meaning into cheaper, accessible hardware isn't just a tech story. It's an energy story, an accessibility story, a who gets to build the future story. That's the real reason I'm telling you all of this. One independent engineer from Mexico asking a question the giants were too busy or too invested to ask. History keeps teaching the same lesson. The next breakthrough rarely arrives down the most famous road. Sometimes it comes from the idea almost everyone ignored, and the person stubborn enough to keep going after the world asked, "Who are you to try?" So here's what I need from you. If you want part 2, where I open up the coprocessor card and walk you through the architecture piece by piece, comment one word below, multibinary. If enough of you do, I build it next, for you. And subscribe to JoyRide Entertainment, because here you don't get hype, you get a real inventor telling you the truth in real time. The revolution doesn't always start with $1 billion. Sometimes it starts with one uncomfortable question. See you in the next one.